Hello everyone, you are watching Code with Shubhajit. I hope you are learning each and every day. And today we will be solving one of the easy problems of lead code, which is rotate a string. So seeing the easy tag, you should not think that okay, it will be very easy. But the thing is that the basic part was easy, but the optimized approach or the actual approach which reduces the time complexity is something which you might not able to think when you first see the problem. Okay, let's understand this problem statement and then we will see what all approaches are there. Okay, so we are given two strings s and goal. Return true if and only if s can become goal after some number of shifts on s. Okay, if I take the example, can you see here that we have the s as a b c d e and we have the goal as c d e a b. Okay, and if you see by shifting it once, the goal comes. Okay, let me go to the OneNote to explain you better. Can you see here that starting from B, C, D, E, and then having the A at the last. So the goal string is the rotated version of the S string. Okay, so that's why we can return true in such case. But let's say if our goal string was something like this, then this will not be a rotated version of this string. Whatever you do, okay, whatever rotation, number of rotations you will do, you will not reach it here. So in this case, you will be returning false. The first thing which you have to understand here is goal should be a rotated version of S, then only we will return true. What it means, it also means that goal and S both should have the same number of characters. I hope that is pretty much obvious. So the first condition would be if goal is not equals to S, then we will return false. Okay. The brute force approach which we can think of is, okay, in this S, in this string S, what we can do, we can actually start from here. Okay, so B. Now starting from here, what is the string which has been formed? So the string which has been formed starting from here is B, C, D, E, A. Okay, so we will check this with the goal. Are they same? Yeah, in this case they are same. But let's say if there is more rotation, let's say if the goal is something like this, E, A, B, C, D, then in that case, we have to actually go to here in the next iteration. The string which will become is C, D, E, A, B. Next it will become D, E, A, B, C. And at the last it will become E, A, B, C, D. And this actually is same as this. So this is one approach which you can have. Okay. But in this case, if you see the time complexity which we are coming with is big O of n square. Why? Because we are going for each of the characters of the string, and for each of them we are creating the whole string again, right? For a single character we are traversing n more times, so that's why the time complexity is big O of n square, and we are taking an extra string for storing that rotated version, so the space complexity is big O of n. I hope this much is clear. Now this is the brute force approach which I can think of. Now going on to the second approach, which is the optimal approach. Okay, so now we have the two strings here, and in this case, if you see that what is our main task? Our main task is to find that whether goal is a rotation of S or not. That is what I have to find. What I will do here, just hear it properly. This is the approach which I am saying that you might not able to see it in the first look. I will write A, B, C, D, E. I will add the same string again. A, B, C, D, E. And now in this whole string, I will find goal. What is goal BCDEA? Yes, I'm able to find this. So can you see what I have done? I have just made this string twice so that I don't need to traverse each character and go back and print them. What I have done, I have just done it one more time so that if a rotation was there, then goal would definitely be present in this string which is S plus S. Okay, two times. It will definitely be present if it is a rotation. If it is still not present, then there is no rotation of goal which can make S. Okay, so I think this approach is something which might, I believe it might not come in the first look. So that's why. Okay, So in Java we have a method, string method called contains. Okay, so we can just write s plus s, this is a string which is this form, dot contains goal. If this is true, it means goal is a rotation of s, and if it is false, then it's not. Okay, I also want you to see that okay, this is a single line solution, but if the interviewer is more keen to understand that that you know that how this contains is working, okay, he might ask that okay, you have written the solution in a single line, but do you know that what the contains do? In that case, what I will do, like what I will say is, yes, I know what contains do. In most scenarios, they will not ask, but if they ask, then what is that? You will say that contains will internally call the index of method. Okay. So if index of method returns -1, in that case, the string is not present or the goal is not present inside s plus s. But if other than -1 it returns, it means that goal is present inside s plus s string. Like goal is one of the rotations of s. Okay. Now they will again ask, okay, this is also an internal method, but what does index of uses? So index of uses one of the variations of KMP algorithm. I will not be covering KMP algorithm because it is out of the scope of this video, but if in future video I make it, I will actually put it in the description, or you can just go through the KMP algorithm by any of the articles. Okay, so in this KMP algorithm, this actually searches a substring in a bigger string, and it does it in O of n time on average. Okay, so if you are able to say it till this point, then the interviewer will think, okay, you have the deep idea of how contains work, how index of work, and what it is using as the internal algorithm. Okay, so now let's get to the code, and it's a single line in code, so it will not take much time. Okay, so the first thing which we'll be checking for is if s is not equals to, if s dot length, if s dot length is not equals to goal. Okay, dot length. In that case, I will return false, and I will return s plus s dot contains goal. Pretty much simple, single liner, just one condition before that, and it's done. I will run the solution and see if the test cases are passing or not. Yes, they are passing. I will highly recommend you guys to actually solve this problem on your own. It is a good, like, it is an easy problem, but thinking about this might be tricky. Okay, so that's why I have explained this solution, because you might get that. And the contains method, how it works internally. Okay, that also I have given a bit idea so that you can go through the KMP algorithm later on. If the interviewer asks about the KMP algorithm, so that you can tell, okay, how does it work? So that's all for today, guys. Hope you like the video. Thanks a lot for watching. If you have any doubts, put them in the comment section. I will be really happy to help.